Hello all. This is the second part of graphing inequalities, and in fact it'll be the last one for graphing inequalities because you did most of the work already in the first video. In this video, we're going to be taking it up a step and introducing systems of linear equations, but graphing inequalities. So what we're going to be doing is we're going to be graphing stuff that looks like this, for example, 2x plus 5 and y is less than negative 3x minus 2. You're going to be graphing two equations at the same time. Well, not at the same time, but I mean like on the same plane. And then you're going to be figuring out which side to shade. So what I'm going to be doing here is I'm going to be color coding it so we don't get lost, okay? The first equation will be in green and the second equation will be in red. So the first thing you want to do is graph both of these equations on the plane or on the grid. So y equals 2x plus 5. That means we're going to have a y-intercept of 5. That's green. And then the slope is 2 over 1, so that's going to be up 2, 1 over, up 2, 1 over, up 2, 1 over, up 2, 1 over, up 2, 1 over. Now, you decide, are we going to, when we draw the line, are we going to make it dashed or are we going to make it bold? There's an equal sign, so that means we're going to make it bold, aka it's going to look something like this. Now from here, you can actually figure out which side of the border to shade. So notice how the origin is not on the line. It makes it a lot easier. So you're going to try the point 0, 0. So we have y is greater than or equal to 2x plus 5. You're going to plug in 0, 0. So you have 0 is greater than 5. So is that a true statement or a false statement? That's a false statement. Okay, 0 is not bigger than 5. What this means then is we're going to be shading not the bottom part, but the top part. So we're going to be shading this part. Now notice how I'm not doing it bold. I'm just like lightly shading that area, okay? We're going to be doing the same thing with the red graph. That's why you don't want to shade it in completely. So now we're going to graph y is less than negative 3x minus 2. You start off with the y-intercept. That's negative 2. Your slope is negative 3, so that means it's negative 3 over 1. So you're going to go down 3, 1 to the right, down 3, 1 to the right, down 3, 1 to the right. You can do this for a good amount of times. And then ask yourself, when we draw the line, do we include the points, right? Is it going to be bolded or is it going to be dashed? Do we not include the points? If you said dashed, you're absolutely correct. We don't include the points because we don't have an equal sign in the inequality. So we're going to go ahead and try to draw the line dashed. Okay? Now, we have to decide which side of the inequality do we graph or shade in. So just barely you could see the origin once again is not on the line, which means you can actually try the origin. So you're going to write the equation. You're going to plug in the numbers. 0 is less than 0 minus 2. 0 is less than negative 2. Now ask yourself, is it true that 0 is smaller than negative 2? Or another way to say that is it true that negative 2 is bigger than 0? If you said no, you're absolutely correct. This is a false statement. It should be the other way around. 0 is bigger than negative 2. So what this means is 0, 0 is not a solution, so we have to shade the other side of the inequality. Now, I'm going to use blue. So you have 4 regions right here. You have region 1, region 2, region 3, and region 4. Right? Since you're cutting this into 2 parts twice, you have 4 regions. The region that's in white is the place where none of those points satisfy any of the equations. Region 1, that's only where the green part is, not the green and the red, but just the green. That's the place where only those points work for the green equation. Region 3, only the red part, that's where only those points work with the red equation. So what do you think region 4 is? Region 4 is the place where all of these points work for both equations. And this is the region that you want to be shading. This region satisfies both of the equations. And what this means is this is the area that you would need to shade. Remember, the shaded area determines solutions. These are the points that satisfy the equations. The 4th region here is the area where all those points satisfy both linear equations.